Okay, second review part 2. Simplify the radical expression. So again, it's just one radical, so what you need to do is split it up. The fourth root of 1,250, the fourth root of x to the 7th, and the fourth root of y to the 9th. Okay, so we make our fourth root here. Some of this will come out, so I'll have some stuff that's inside of it. So I start the division, okay, because I look at my fourth roots and 1,250 is not there, okay? So I got to start dividing. So I make 2 fourth roots, okay. So I take 1,250, and I'd start right here, the 1,000, actually 625 would be your first one to start at. That works right away. I get 625 and 2. So I get rid of that because the fourth root of 625 is 5. So what happens is 5 goes out, 2 goes in. And for the letters, we got x times x times x times x times x times x times x. And we group 4 of them at a time. So x comes out. X does not come out here because I couldn't get 4. So I put x outside. And then x to the 1, 2, 3 third power inside. Then y to the 9th, y times 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 y. So we got 4, a y comes to the top. Then another 4, y comes to the top, then this last one. So I got y to the 2nd, remember that's outside, because 2 there, and then a y inside. Okay, and now it's simplified, just like that. Okay, next one, so we got the cubed root of 8, the cubed root of x 7th. Now a little interesting thing happens when I look at my cubed roots. 8's on here, I just put equals 2. Now remember, that goes outside, that 2 does. When that happens, nothing will be left over inside. X times x times x times x times x times x, okay, times another x. So again, 3 at a time, because it's a cubed root. Every time I do that, an x can come to the top. And how many x's you got on top? You got 2, so it's x to the 2nd here, and this x here remains. So it's 2x second cubed root of x. Okay, number 3, you're doing the same thing. You just got a little extra step. You need to just make it into 1. By the way, these are 2's, okay, if they don't have it. So I put my 3 outside of here. This one doesn't have an outside. Then I take 12 times 14. Got 168. And with the x's, remember, these are to the first, and we just add the powers, and it's x second. Now it's the same thing we have going on here. So I got the square root of 168 and the square root of x squared. Okay, so when I make my radical with a 2, remember the 3 is pushed out, okay? And when we got an outside to start with, we push it out. Then I need to see what I can maybe divide 168 by from my list of squares. So 168 divided by 144, decimal. 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 Boring. Decimal. Come on. I already tried that. Decimal. 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 Finally, I got something that worked, okay? That took a while. 4 and 42. So the square root of 4 goes to 2. So the 2 goes out, and it's a times 2, and then 42 remains inside, okay? And also 3 times 2 is 6. You might want to put that there. Now as far as the x's go, you got x times x. And an x comes outside. I'm not going to have x inside. So there it is, 6x square root 42. Okay, next one, same idea. These are square roots. So first thing, I take 2 times 10, which is 20. And 2 plus 3 is 5. Now this time, instead of 1 outside, you got 2 outside factors, 3 and 5. So multiply those, you get 15. Everything's the same. Got the square root of 20, square root of x to the 5th. Okay, so I rewrite my radical. 15 gets pushed out. Anything else outside there will times by 15. So 20 divide into 20. 20 divided by 16 is a decimal, 9 is a decimal, 4 and 5. So that's 2. So I put a times 2 outside and a 5 inside. And 15 times 2 is 30. Now as far as x's go, we have x times x times x times x times x. So 2 at a time. So that's 2 full x's to x to the second, 30x to the second. Then we have an x inside, so 5x. Okay, now simplifying by adding or subtracting, you got to check under your radicals and see if they're the same. They are. So I can make my radical 3m. 18 minus 25, I can do that operation now because they're the same. It's negative 7. Okay, now my next one, we see this time we got 3 of them. So we're going to come over here and make a table. And they're not the same, okay? All these are different. So we want to try to rewrite them so that they're the same. So we got the square root 75, 2 square root 48, and 5 square root 3. Okay, so 75 isn't here, so I divide. Now I would start at 64. So 75 divided by 64 is a decimal. 75 divided by 49 is a decimal. Divided by 36, a decimal. Cha-ching. 25 and 3. Okay, so this becomes 5. So it's 5 square root 3. Okay, square root of 48. Now when I rewrite this, 48's not here, so I drop my 2. 2 times square root times square root. So 48 divided by 36, a decimal, divided by 25, decimal, divided by 16, decimal, divided by 9. Or no, 48, I'm wrong, sorry about that. 48, not 45. 48 divided by 36. 48 by 25, 48 by 16, cha-ching, okay? So I put 16 and 3, and I rewrite that as 4. So now I have 2 times 4 times the square root of 3. 2 times 4 is 8. So I now have 8 square root 3. Now the other one, well 3 is not a long number, okay, so you'd start at 1. 3 divides by 1, okay, so 5 times square root times square root, because I know I can take 3 divided by 1 and I can get 3, so I put 1 and 3. So that's 1, okay, so I got 5 times 1 times the square root of 3. 5 times 1 is 5, so really it didn't change, but that's okay, or minus 5 radical 3. So I have radical 3, and now I'm allowed to do the outside operations. 5 plus 8 is 13, minus 5 is 8. Okay, it says FOIL. So 3 times 8, 3 times negative 20, but negative 20 has a square root radical 2 next to it. I go to 2 and 8. 2 has a square root of 2. The 8 doesn't have anything. It's a constant. Then 2 times negative 20. The 2 has a square root of 2, and so does a negative 20. So 3 times 8 is 24. 3 times negative 20 is negative 60, radical 2. 2 times 8 is 16, radical 2. 2 times negative 20 is negative 40, but I have to multiply the numbers under the radicals. 2 times 2 is 4. Now, the square root of 2 isn't here, so I'm just going to leave those alone, but the square root of 4 is. That equals 2, so I need to write that as negative 40 times 2, which is negative 80. Okay, now I would add these because neither one of those have a square root anymore, so I take 24 plus negative 80, negative 56. In the middle we got the same radical, so that allows me then to add the outsides. Negative 60 plus 16, negative 44. Boom. Okay. Number 8, simplify. Okay. Now ready to simplify a negative exponent. First off, you put a 1 over it. Now remember the rule with a fraction. We look at that 3 and the 27. This is a radical. The 3 is a root. Okay. So I look up the cubed root of 27. And I see that's 3. So I have 1 over 3. But remember, don't forget about the 2. You still have 3 to the second. And 3 times 3 is 9. So that's 1/9. Okay, now solving equations for x. Okay. So look at your radical. Outside we got a plus 2. Well, we're going to have to minus 2 then. That takes me to 2. We have radical x plus 5. So you have to take both sides then to the second power to get rid of the radical. 2 to the second is 4. And then we subtract 5 from both sides, and x equals negative 1. Excuse me. Okay. Number 10. When I see that parentheses with that power, we want to get rid of the parentheses with an h. You can't distribute because of the power right there. So 4h to the power of 2/3 equals 16. And then later, I bring back the x minus 2. Now look at your top. This time that's an even. Okay. We look at the top. So I would need both sides. So I divide both sides by 4, and that's 4. Then we take both sides to the 3 over 2 power. Okay, the 3 over 2, you just flip it. Remember what this means. The 2 is the root. Okay, so I would look up what the 2 roots, and that's 4. That equals 2. So h equals 2 to the 3rd power. So 2 to the 3rd means 2 times 2 times 2. That's 8. H is equal to 8. So on my table, I go 8 on one side, negative 8 on the other. So I plus 2, I get 10. Plus 2, you get negative 6. Okay, number 11. Got anything outside your radical? I don't think you do, so you can go ahead and get rid of the radical. So on this side I've got 3x plus 3. The x plus 1 to the second power you need to FOIL, and that means you're going to have to use eventually the quadratic formula. So you're going to take x plus 1 times x plus 1. So it's going to be x times x times 1, 1 times x, 1 times 1. So that's x to the second, 1x, and 1. So we have x squared plus 2x plus 1. Now, don't do the quadratic formula off this side. You can't use the quadratic formula until you have 0 on this side. So we're going to need a minus 3x from the 2x, and then minus 3 from the 1. 2 minus 3 is negative 1x. 1 minus 3 is negative 2. And now it's quadratic formula time. So, opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. That always results in 2 solutions. So the opposite of negative 1 is 1. And then b to the second, so it's going to be negative 1 to the second. 4a is going to be 1. C is negative 2. And a is 1. Okay? So we got 1. 2 times 1 is 2. Now we got to find what that square root is. Okay? So I take negative 1 times itself. That is 1. Okay? Negative times negative is positive. 4 times 1 times negative 2. That is going to be negative 8. Plus plus, that's 9. And if I square root 9, it works out beautifully because it goes right to 3. So 1 plus 3 is 4, and then divide that by 2, I'm at 2. 1 minus 3 is negative 2. Divide that by 2, you get negative 1. Okay, now the graphing. Graph the equation, identify the domain and range. Okay, domain and range, remember to do that down here. Okay, so a square root, 0, 1, 4, 9. Okay, and then the square root of 9 is 3, square root of 4 is 2, square root of 1 is 1, that's 0. That's the parent function. Now, do you have anything inside the radical? No, if you don't have anything inside the radical, then your x's are set. Now, outside the radical, you have a times negative 2 and a minus 3. So all the y's we have to times by negative 2 and minus 3. Just do both operations at the same time. 3 times negative 2 minus 3 is negative 9. 2 times negative 2 minus 3 is negative 7. 1 times negative 2 minus 3 is negative 5. 0 times negative 2 minus 3 is negative 3. Okay, so plot this point, the 0, negative 3. 1, 2, 3. So 0, comma, negative 3. That's x, that's y. 1, negative 5, so forward 1, down 1, 2, 3, 4, 5. You don't need to label that point. 4, negative 7, forward 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6, 7. 0, negative, or 9, negative 9, so 9's all the way to the end, and negative 9's all the way down. Okay. Now, only an arrow goes off that end. Okay, now domain and range is based off that first point, 0, negative 3. So I make a straight vertical line, and all points are to the right of that. So that means it's greater than or equal to on the x-axis. Okay, then as far as the range goes, I make a horizontal line through that point. And all points there are below. Okay, so if they're below, we use less than or equal. Okay, 13, same idea. 9, 4, 1, 0, 3, 2, 1, 0. Okay, now you got something inside the radical that you need to cancel out. How would you do, so what's the opposite of a plus 6 if you didn't want a plus 6? It'd be a minus 6. So 9 minus 6 is 3. Because see, if I put 3 plus 6, that's 9, which is what I originally had, which is good. 4 minus 6 is negative 2. 1 minus 6 is negative 5. 0 minus 6 is negative 6. So we took care of that. Now the only outside operator is minus 4, so I'm minus 4 to all of those. So 3 minus 4 is negative 1. 2 minus 4 is negative 2. 1 minus 4 is negative 3, and negative 4. So graph this point first and label it. So negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So negative 6, 4. That's x, it's y. Negative 5, negative 3. 1, 2, 3, 4, 5, 1, 2, 3. Negative 2, left 2, down 2. 3, negative 1. 1, 2, 3, down 1. Okay, so I've got negative 6 for x and negative 4 for y. So I make the vertical line and everything's to the right. So again, that's greater than or equal to. Then I make the horizontal line and everything's above. Okay, so above. So this time it'll be greater than instead of less than here. Because see here, everything was below that line. When I make it here, the graph is above it. Okay.